Hello and welcome to my presentation. My name is Schibili. I'm based at Mettler Toledo in Switzerland. Within Mettler Toledo, I'm marketing manager for the Industrial Internet of Things or Industry 4.0. I'm responsible for weighing in production. In the next 10 minutes, I'm going to introduce you to how Mettler Toledo implemented OPC UA into weighing equipment for manufacturing. Thank you for attending my presentation. To start my presentation, please allow me to introduce Mettler Toledo. Mettler Toledo produces and services measuring instruments along the entire value chain, from incoming of goods to laboratory to production, quality control, logistics, and finally for retailers. Our products are used for manufacturing of pharmaceuticals, chemicals, food, automotive parts, plastics, raw materials, and for logistics for these industries. The company has 16,500 employees. We have a turnover of a little bit more than $3 billion. A remarkable fact of Mettler Toledo is that we have more than 8,000 direct sales and direct service specialists all over the world. With this large number, we are one of the largest global service organizations among precision instrument manufacturers. On this slide, I explain the current and also the future communication architecture in industrial production. On the slide, you see two different architectures. The triangle on the left is the well-known SCADA pyramid. It includes, from the bottom to the top, data exchange in industrial production, from sensors to actuators, to machine control, to process control, to the MES, to the ERP, and finally to the cloud. In the traditional SCADA automation pyramid, data is consistently forwarded in a systematic step-by-step process following the hierarchy. Communication is via networks such as Profinet and Ethernet IP, but realistically also serial point-to-point connections such as RS-232 or even 4 to 20 milliamperes. On the right-hand side, you see the illustration of any-to-any. Any-to-any stands for everyone communicates directly with everyone. With any-to-any applications, sensors and actuators communicate directly. The communication ignores the strict hierarchy levels of SCADA. I have to point out, today time-critical data is not communicated via any-to-any, but this will change in the future. On this graphic, you can see the distribution of the communication technologies. On the vertical axle, you see Ethernet not deterministic, and at the bottom, industrial Ethernet deterministic. On the horizontal axle, you see small data volume time critical, and on the right, large data volume non-time critical. On the right-hand side vertical axle, on top is MES ERP Cloud, in the middle machine-to-machine control, and at the bottom sensor to machine and sensor to sensor, sensor to actuator. The blue field here illustrates the territory of OPC UA and MQTT. The green surface here illustrates the territory of Profinet, Ethernet IP, and other such technologies. In the middle, we have the mixed zone. In the mixed zones, both technology groups are being used. And who uses what depends on the industry, on the customers, and on the applications. Here is the same graphic again. So what kind of evolution can we expect? We will receive Ethernet time-sensitive network. We will receive OPC UA pops up. we will receive OPC-UA field level communication, and it will become common that multiple communication technologies share one network wire. These new technologies will change the size and placement of the territories shown. The blue zone for OPC-UA and MQTT will grow. The green zone for Profinet, Ethernet IP and other technologies will shrink. The mixed zone will grow and move down because new technologies change the landscape. The described scenario poses a challenge for an equipment manufacturer. We asked ourselves, when does the above scenario become reality? What do we offer to our customers today? How do we implement OPC-UA for the whole product range? And how do we upgrade the installed base of our customers? On the previous 3 slides, I showed you the situation we were facing as a weighing equipment manufacturer. On this slide, I will show you our solutions and the benefits our customers have from it. This part of the picture illustrates the weighing equipment environment which we have to connect to the MES, ERP and to the cloud. This part of the picture illustrates MES, ERP and cloud environment. To connect these two environments via OPC-UA, we introduced the ACI 400 edge device. The ACI 400 includes an OPC-UA server with the companion specification for weighing. The solution with an additional edge device, as shown here, creates a win-win situation. For Mettler Toledo, it has the benefit that it allows to connect the entire existing product range via OPC-UA to the MES, ERP, cloud environment. We have to maintain one device only. The second winner is our customer. With this edge solution, he can connect all new and all existing weighing devices from Mettler Toledo via OPC-UA to the MES, ERP and to the cloud. In parallel to the OPC-UA connectivity, he can still communicate with Profinet and Ethernet IP according to the SCADA automation communication pyramid. As a result, he can combine old and new architecture, meaning any-to-any and SCADA, and finally, the customer has OPC-UA communication that uses the companion specification for weighing. I'm at the end of my presentation. Thank you for attending. I'm hoping I could give you some interesting information. In case you have questions, you can see my email address, eugen.schibili@mt.com. Thank you very much, and thank you to Stefan Hoppe for organizing this very, very interesting event. Thank you very much.